So residuals from the first regression is a part of the explanatory variable that is uncorrelated with the others. So we are taking out only the pure part. What I mean here, the pure is the some part can be explained by the other variable. So we can take it out that part, or the only pure x1, that variable part. And then if you calculated that coefficient, then that should be the same. So this is like an isolated effect of that variable. Goodness of fit is still we use r square. Yeah, the formula is still same. Sum of square total, sum of square error, right? So we can calculate exactly the same r square as we did. And then this is the alternative expression of r square. So r square is just you can interpret how much my model can explain my dependent variable. Okay, this is the what I just did. Yeah, actually the variable they use is a little different here, right? However, this is the same data what we use here. Yeah, of course we can do the Excel. Yeah, I will show you how to do it in the Excel. This is a crime one data, but I don't know which one is which one, so I have to open. Okay, number of arrest 86. This is the first one, and then we need the fourth one. Let me see what was the PCNV and P time and QEMP. So PCMV is a proportion of the prior convictions. Okay, fourth, and then seventh and eighth, right? Fourth, seventh, eighth. We are so for first one, fourth one. This is 4, 5, 6, 7th, and 8th, right? Maybe I can just simply add. This is a NARR86, right? This is the PC and V. This is what? This is the P time 86. This is a QEMP 86, right? So one problem of this Excel case is the, let me see, it's changed. Regression. So I want to choose the y variable. This is my y variable. X variable, the problem is, can I choose holding control? Yeah, I can choose. So I'm choosing my axis, and then I check label because my first row is the label. So that's why I'm taking it. And then I will just do the regression. Yeah, actually they cannot do that. So the problem is that you have to put all these things together. So what I'm gonna do is I'm gonna move this to and move here, shift right and move. Then now I can have everything together. Now I can bring it back. Yeah, I just simply expected that they might have a fix this problem, but still there is some problem. And then you click OK. I think I will have to choose from here, and then I will find out. Here. So simply you can just press the Control and Shift and then arrow down. You can select the all things. And then this one also, I will go up. From here, use hold Shift and Control and move down. And then release Control, because I want to select the multiple area, but not moving extreme point. I'm just moving right arrow, and then I select all 3 rows. Label, we have a label because the first row is label, should not be used in calculation. And if you click OK, then you should have this one. So as you can see, the coefficient of the PCNV is this one, 0.14993. This is the same, right? And then you can see the F statistics, p-value here, and then also p-value here, everything. So you can do the same thing on R, right? So I will do the R. Now rest is 4, linear model, and then number of arrest 86 with the what was that, the PCNV plus P time 86 plus QEMP 86, and then summary arrest 4. Then you can see the coefficient is 0.7, 0.1499 and 0.03, right? So if you look at the Excel, so you have exactly the same number, 0.71. Let me see. You can compare here and here, right? Intercept, coefficient of the PCNV, and then coefficient of P times, and coefficient of the QEMP, and also the p-value, right? So p-value you can find. This one is is too small, you cannot calculate it. So this is too small and this is too small. So you can get exactly the same result. But here, in the slide, what we're trying to do is what if we add the AVG sentence, average sentence. So I can do this simply here, plus AVG SEN. Summary of the arrest 4. Oh, it should be the large A. Now you can see that it's a little different. And then if you take a look at the R square here, where is the R? Here the R square. Excel also provides the R square here. R square can be found here. So R square this is the without average sentence, was a 0.041. Now this is a 0.042. So R square is always increase. It cannot be decreased because the new variable, new added variable, if you assign coefficient 0, then that model will be the without that new variable, right? So always we can choose 0, but we optimize it, which means worst case you have exactly same r square, or whenever you add a new variable, r square will be goes up at least a little bit. So even in reality, even though you just put the addition of factor that doesn't relate it, or it doesn't have any prediction power, but still your r square will be go up tiny bit. So we will talk about that on the I think it's next chapter, when we talk about how we select the factors, model selection. Okay. Okay, this one shows we added a new value, and then you can see that your r square is a tiny bit of increase. So average present prior sentence increase the number of arrests, isn't it? Because it's a positive coefficient. But as you can see, that doesn't increase our r square very much, so it has a very limited explanatory power. So you can say that doesn't have enough power to cover up the in prediction of number of arrests. So even if r square is small, the regression may still have provide a good estimate of the ceteris paribus effect. That's why when we think about, r square can be very small because there's a lot of different factors which are important. Because you didn't include that factor, that's why I cannot fully explain. I cannot explain enough of my dependent variable. But small r square does not mean my factors has no effect on my dependent variable. That's why we have a t statistics and then f statistics. There is several assumptions of multiple regression, but they are quite similar to the simple regression. First one is a linear relationship. They are linear again. X1, X2, X2 can be a X1 square, but they are linear in parameters. And then random sampling. So we use sample that is randomly sampled.